Hi again everyone, let's look at our car color combinations data in SAS Studio. The first thing we've got to do is open up our data. So we'll go here, double click on our car color combinations data, change our output data to something that we'll remember, car colors, and hit run. Take a look at our data, make sure it's imported correctly, and everything looks good. We've got our 12 combinations of exterior colors with each of 4 exterior colors with each of the 3 interior colors, and we've got the counts that we've observed for each of the combinations. Okay, to analyze this, we're going to go to tasks and utilities, and we're looking at one-way frequencies this time to do our chi-squared tests. We'll tell SAS Studio that we're working with the car color data. There we go. And for analysis variable, we're going to tell it, first off, to use the exterior color data. What's really nice now is that we're not going to have to do any calculations ourselves. SAS Studio is going to do those all for us. Over on the options page, there's something that I forgot back here on the data page. I need to tell SAS Studio that we have count data. So there is our count. Actually, let me show you what happens if we forget to do this. We can go to options here. We want to tell SAS Studio to use the chi-squared goodness of fit test, the asymptotic version. We'll hit run, and you're going to see a mistake here. All of the exterior colors are equally likely, and they've all been chosen 3 times. Okay, that's not right. So what's happened is that because in our data we have 3 observations with 3 lines for each exterior color, 1 line for each of the interior colors, SAS thinks that we've only got 3 observations of each one, but if we tell it that we've got our count data and hit run, now we should get the same result that we had in Excel, and everything's looking pretty good so far. Those are the correct frequencies. Remember, our chi-squared test is asking, are these percentages far enough away from being equal for us to say that the true underlying distribution of preferences here is not one in which the colors are equally preferred. Our chi-squared test value is down here. We've got a test value, a test statistic of 3, the same as we got in Excel, and that gives us a p-value of 0.396, again, same as what we got in Excel. This is bigger than 0.05, so we do not reject our null hypothesis. We stick with our null hypothesis and believe that all of the colors are equally likely to be chosen. Okay, we have our second variable that we can test, our interior variable, but you know what? Everything is going to be super duper easy here. If we go back over here to our options under data, we can just add in interior as another analysis variable. Click run again, and we should have a second set of results that refer to interior color. And yep, here we go, 49% of people, 98 chose a black interior, and about 50 chose cream and grey. There's a graph of those. And there is that same chi-squared test that we calculated in Excel. A chi-squared test statistic of 22.12, with an associated p-value of tiny, smaller than 0.0001. There's a less than 1 in 10,000 chance that we would have got results this extreme if black, cream, and grey were actually equally likely to be chosen. So we go ahead and reject our null hypothesis of equality here in favor of the alternative that the interior car colors are not equally likely to be chosen.